Hello, my name is Lana Chan, and I'm a product marketing manager here at Cadence Design System for its PCI Express verification IP. This Whiteboard Wednesday session is a third in a series of Whiteboard Wednesdays covering the evolution of PCI Express and what it holds in the future and the challenges that we're seeing. In today's final session, what I'll be covering is the changes for Gen 4 and just exactly what we're looking at in the future. So PCI Express Gen 4 is upholding what its predecessors have done, which is backward software compatibility, low power, low cost solution, while increasing its bandwidth. And this has posed market challenges for designers. The first protocol enhancement that I'd like to cover is protocol timers. For this latest revision, the protocol timers have been simplified. Why do you want to simplify it? You want to be able to reduce the logic associated from one generation to the other. And when you reduce the logic, your chip design gets simpler, your power consumption hopefully is lowered, as well as your chip size. The second item is flow control. Flow control scaling was introduced in this latest revision. Previously, flow control credits did not depend on the link speed. Although we've increased the bandwidth, the latency itself has actually not increased marketably. As a result, what you're looking at is you can run out of flow control credits before you actually fill up the pipe to its full potential of 16 gigatransfers per second. So with scaling, what we're seeing is that you end up having more credits. You're scaling the credits such that you're filling up the pipe. Next, I'd like to talk about RX margining. RX margining entails that your software is able to determine the margining of your end device with it and adjust the link such that you're having a good signal go across the line and you're recovering data with good reliability. This is especially important at 16 gigatransfers per second, where there are enough challenges from a physical perspective trying to push out all those bits and bytes so quickly. And then finally, retimers. In Gen 3, we already saw the introduction of retimers, but with the advent of 128-bit, 130-bit, they were still able to reproduce, to give you the doubling of bandwidth at 8 gigatransfers per second without necessarily making use of retimers in order to account for signal integrity at the higher speeds. At 16 gigatransfers per second, that's just simply impossible. What we're talking about is traces about 12 inches at 16 gigatransfers per second versus traces of 16 to 20 inches at Gen 3 speeds. And this is where a retimer, which is essentially a repeater, comes into the picture, and it's required for Gen 4. So these are the major 4 changes that we've seen for Gen 4. At the end of August, we saw the release of Rev 0.7 of the spec finally released. This was after much delay. We're now looking at 6 years after Gen 3. And people at the SIG were at the most recent PCI SIG developer conference were already asking what's in store for Gen 5. Because to be honest, folks have already been saying PCI Express is late. Are we going to be still squeezing out the last breath out of the copper technology, or are we going to actually have to look at the optics? These are all important questions that designers are looking at, as well as, and they've already pushed forward with their designs before the spec was ratified. With all this said, and with the spec changing and a certain amount of uncertainty, it is especially important for a verification environment to take into account these changes as they're occurring, for it to be a reliable solution, and for you to actually have measurable statistics saying that you've covered everything within the spec. And this is where Cadence's PCI Express verification IP comes into play. with that, we'll have to see what's going to happen in the next coming years, whether or not we can crank up copper technology a little bit further, or else have to resort to optics, which invariably comes the question of at what cost. Thank you very much for joining me on this Whiteboard Wednesday, and I hope you've learned something. Thank you.